Okay, hello again. So now you must be viewing the graphic user interface for the program. First of all, what we are going to do is to import the geometry which we are going to analyze, the floating object. In this case, it's a semi-submersible structure. So let's begin. We can import the geometry easily. As you can see, there are plenty of standard formats and also standard available for importing the geometry. In this case, it's an IGES. So just look for it in a computer. You can see here you have this IGS file. You just click to open. So after the import operation, the program gives us some information on this operation. Just doing some collapsing and correction of geometry, as you can see here. Okay, so now you can see we have the geometry already in the graphic user interface. We can render it so you can see it even better here. So this geometry is just cut at the floating surface. So we are just going to analyze what happens from the zero height and below. And the next process would be to create the domain for the analysis, the fluid domain, which for this type of analysis, the most indicated is cylinders. So we'll create a cylindrical fluid domain. And for doing so, we are going to create first the cylinder base, which you can see here. We are going to create a cylinder, a circle, which will be introduced by its center, which is asked by the program. So we just introduce the center in the command line. As you can see, all the model and all the domain is in the origin, center in the origin, but the bottom of the domain would be in this case, we will explain it later how this works, but in this case it's going to be the bottom is going to coincide with the depth of the domain we are analyzing. So in this case is minus 120 meters. You can see here in the command line where I introduced the center. You can see here is marked in yellow. I shall continue. Well, the center is introduced. Now the program asks to enter the normal for the circle. It will be in the positive set. And finally, we'll ask for the radius for the circle, which in this case is going to be 80 meters. We are going to create first an internal cylinder, smaller one, and then a larger one around it. This is just for meshing issues, so we can refine the mesh near the object. So in this case, the inner cylinder would be 80 meters radius. So as you can see, one circle has been created. And now we're going to create the bigger one. of course the center is the same. So 0, 0 minus 120 meters. Also the normal is the same, the positive set. But in this case, we are creating the larger circle, and this would be 1000 meters of radius. So there we go. We have both bottom circles. And now, interesting thing to do now is to organize all the geometry in different layers, so it would be easier to visualize and to apply conditions. So just here, click to visualize the layers window. You can see there are already 2 layers created. I'm going to rename one of them and use it for the exterior cylinder. So just call it X cylinder. And send the circle surface to that layer. So just select it. And now the circle is in such layer. I'm going to change the render to a normal one, so it is easier to visualize the geometry. And let's create another layer for the internal cylinder. Call it internal cylinder. And let's send the internal bottom circle surface to that layer. Okay. Now, as you can see, we have already a layer which is corresponding to the body, to the floating object. You can disconnect it, so you can see what I'm referring to. You can see now it disappears, and I connect it again, and you can visualize it again. So let's create another one, which we will use later, another layer for the free surface. Here, layer free surface. And also let's create two more layers for the volumes. So we'll have in separate layers the surfaces of the cylinders and the volumes. So internal volume, one layer. And another one called external volume. Okay, we will use them later. So now we are going to create the cylinder walls from the bottom. So we'll select the interior cylinder layer. And for doing this, we'll use the entities copy tool. You can see here a new window appears, and here we'll do a translation operation to copy the lines of the contour of the bottom surface. So in the same operation, we're going to perform an extraction of this line, so the lateral surfaces of the cylinder will be created. So the entity to copy is lines. Transformation, of course, is translation. And we are going to choose the beginning point of the translation and the end point. We select twice the beginning point, and then we change the set coordinate of the end point, so it would be the lines will be copied up to the free surface, which is the corresponding to the set equal to 0 coordinate. Here we choose to extrude surfaces, and that's it. We select the corresponding line and we perform the extrusion. You can see here, I'm going to render it so you see it better. See, we have the internal cylinder created. Okay, we can do the same operation with the external cylinder. The same initial and end point will do for this operation. It's the same transformation vector. And the only difference is that we are going to select exterior cylinder layer and select the lines corresponding to the exterior cylinder. Okay, so there you go with external cylinder wall. We can close this window already. So the next step would be to close the cylinders on the top part, the part corresponding to the free surface, then hold those surfaces, and then just create the volumes. So now we are going to shift to the free surface layer. And I'm going to create the surfaces corresponding to the free surface, which is the top of the cylinders. And choose the lines. So we have got one created. And also going to create the interior one, the same layer. Okay. And right now, the only thing left to have the geometry properly defined is to hold the free surfaces with the corresponding cylinders. So we have this addition utility, which is exactly what we need. It's whole new surface. And the program asks to select the surface to hold and the lines to create the hole. So we select the line and we have the surface of the exterior cylinder held by the walls of the interior surface. Now we are going to do the same operation. We're going to hold the interior cylinder surface with the floating object. Select, sorry, not that one. And we select the lines corresponding to the legs of the semi-submersible structure. Go, have one hole, and the same operation is done with the 4 legs. You see, the holes are being created. So the only thing left is to hold the bottom surface. So we're going to do the same operation. Again, geometry, edit, whole new surface, and select the bottom surface in this case, and the lines of the interior bottom surface. And we got the hole created, so we are done with making holes in these geometries. Now, what's left is to create the volumes, so we can have the properly defined analysis domain. And we are going to use the interior volume layer for creating first the interior volume. And this volume is going to be its contours are the interior cylinder surfaces and the floating body surfaces. So we can disconnect the rest of the layers. Here you can see. So for creating the volume, we can do either on the menu, options, geometry, create, volume, by contour, and select all the surfaces. So just a minute. Having some issues with the connection. Okay. So, sorry for the interruption. Let's try again. You can see my screen right now again. So, I'm going to repeat this operation. Create the volume by contour. Select the surfaces. Show it in a flat render so it's easier to visualize. So now we have the top surface missing for defining the whole boundaries of the volume. So we need to switch on the free surface layer and select the top surface. And with this, the volume is created. As you can see in the lower part in the command line. I'm signaling it right now so you can see here in yellow, smart, it says created one new volume in the layer interior volume, which is the thing we wanted to do. So we are going to create the other volume, exterior volume. For doing so, we're going to select the free surface. Also, we're going to switch off the body layer, so we don't have to worry about selecting wrong surfaces. Just select the lateral surfaces of the interior cylinder. And I'm going to activate the exterior cylinder so we can select also those surfaces. You can see the only one missing is the bottom surface. Also we have it selected, and now as we want this volume to be created in the exterior volume layer, I will just double click it in the layer windows, so making it the active layer, and now we just can hit the command so the volume is created. Okay, as you can see also in the lower part of the interface, you can see that the program informs that a new volume has been created in the exterior volume layer, which was obviously what we wanted. So now we have all the geometry properly created, the two volumes. I'm going to do a normal render so we can signal the volumes. So here, the utilities menu, you have this list tool, which will allow you to choose the volumes. In this case, 2 volumes should be selected, as you can see. Two volumes. You can see it in the lower part of the interface, which will always inform of any operation you perform. And of course, the output of this command is the list of the entities we have selected. In this case, the 2 volumes. You can see the number of the volume, the layer to which it belongs, and also all the contour surfaces of the volume. So, okay, now we can close for the moment the layer windows. We have created all the geometry. It's very interesting, but the very interesting thing starts right now. We are going to perform all the necessary operations to set up the analysis for seakeeping. In this